Yes. One by one you solve it. I'll give you that. Yes, darlings. Do this question. The radial probability distribution curve of an orbital of hydrogen has 4 local maxima. If orbital has 3 angular nodes, then orbital will be. Do it fast and tell me the answer. Yes, Yoganand Reddy, excellent. Tell me.
Sir, option A 7F.
7?
Yes.
Excellent. Excellent. You did good job. Why it is the probability distribution curve of an orbital of 4 local maxima. Yes, remaining student, anybody having the doubt? Preetham?
Sir, 7F only, sir.
Sir? 7F.
7F.
Good boy, good boy. Okay, so the thing is n minus L minus 1 is equal to 4. That maxima is nothing but the number of radial nodes. Absolutely. Okay, that means n minus L minus 1 is equal to 4. The orbital has 3 angular nodes. Angular node L is equal to, angular nodes formula L is equal to how much? 3. Yes or no? Then you put L equal to 3, that is n minus 3 minus 1 is equal. Oh no, sorry. I did any mistake? Here I did mistake. Yes. The maxima are 4, then automatically nodes are 3. Okay. Maxima is 4, automatically nodes are 3, that is n minus L minus 1 equal to 3. Already he said angular node, L is equal to 3. You put L is equal to 3 there. That n is equal to, you bring that side, so 4 plus 3, that is equal to 7. If n is equal to 7, L equal to 3, that is 7F. Why? Because L equal to 0, L equal to 1, L equal to 2, L equal to 3. S orbital, P orbital, D orbital, F orbital. Now, how do you take n minus L minus 1 equal to 3, sir? Sir, maxima having 4 maximas. Logic is here, for example, Lana. Like this. 1 maxima, 2nd maxima, 3rd maxima, 4 maxima. Then number of nodes become 3. That is radial nodes become 3. N minus L minus 1 equal to 3. Already orbital has angular nodes 3. L equal to 3. That is automatically you are getting 7F. Anybody having the doubt on this? I think nobody. Now I'll go for one more question. Now see this question, students. Yes. Sai Shankar. Sai Shankar. Divit Reddy.
Sir, how do we know that it's safe, sir?
Sir. Repeat one more.
Sir. Sir,
Tell me, Nana.
how do we know that it's 7F, sir?
How do you know that it's 7F? How do you know, Bangaro?
Yes, sir, 7, it came, sir, F.
They give n equal to what?
7.
You got 7. L equal to what you got? 3.
3, sir.
7 means 7. L equal to 3 means F. That is why 7F.
Sir, how do we 3?
Sir,
How do we know that it's L is equal to 3, sir?
L equal to 3. Angular node. Angular nodes. Number of angular node L equal to 3. Angular nodes
sir.
formula. Number of radial nodes equal to n minus L minus 1. Number of angular nodes L equal to this n minus L minus mean radial nodes. L equal to mean angular nodes. Understood? Next. One more. Akash Kumar.
So then
Sir,
why? How do we equate it to 3, sir? Then
Sir. Divit or Akash? Akash?
Sir, can you once discuss in short the theory of this wave mechanical model?
Theory is nothing but by doing so problems itself you can get now. Okay, na?
Okay, sir.
By taking one by one problem I am explaining. Don't worry.
Okay, sir. Thank you, sir.
Divit Reddy.
okay, sir.
Srinivas.
Sir, option A, 11th questions answer, option A.
For next question,
Yes, sir, yes.
I am going for that also. Very good boy. Next question option is saying A. Absolutely correct answer. How could he say that answer as A? Okay. For your convenience, student. Yes. Somebody has asked me, sir, could you please explain all of them? Yes, I am showing to you. Wait. You see everybody this? Yes. This is the thing you see. Sir, actually psi. What is psi? Psi is called wave function. Electron wave function. In the Schrodinger wave equation, dou square psi by dou x square plus dou square psi by dou y square. Is it right or not? In this one, this is a Schrodinger wave equation. To solve this wave equation, okay, we are converting the Cartesian coefficient x, y, z. This x, y, z are called Cartesian coefficients or coordinates. Cartesian coordinates, I am converting them r, theta, pi. That is called polar coordinates. Sir, why do you are converting x, y, z into r, theta, pi? Solvation of psi in Cartesian coordinates is typical. Yes, to solve this equation, to solve this Schrodinger wave equation. What is this? Schrodinger wave equation. Yes, Nana. To solve this Schrodinger wave equation in terms of x, y, z is typical. To get the psi value. To get the psi value in terms of x, y, z is typical. That is why we are converting this Cartesian coordinate into polar coordinate. That means we are converting psi of x, y, z into psi of r, theta, pi. Yes, students, carefully observe. Wait for 1 minute. I am closing the door because other lecturers are getting disturbance. Yes, I am in college. I am teaching, okay, our classes, all of them from our college itself. Because I am waiting for you. If you come here, we are very happy to that. But the situations are not demanding us. Now, these are called Cartesian coordinate. That means I am converting the psi value in terms of x, y, z into r, theta, pi. a polar coordinate. Under the psi value, I want to solve from the Schrodinger wave equation. So in the solvation, in writing of the answer XYZ is typical. That is how we are converting into R theta pi. How we are converting? No lecturer will give you. Nobody will give the answer for that. But I have written all that. That is x equal to r sin theta cos pi. Y is equal to r sin theta sin pi. Z is equal to r cos theta. How do you convert it, sir? So for that one, I have given all the solution. I have converted x, y, z value into theta pi. You see otherwise. Now you see x coordinate. X component is sin theta cos pi. They given sin theta cos pi. Some student have asked me, sir, could you please explain the topic? If I explain the topic, you will get again bored. That is why I am explaining by taking problems. You see in this psi solution, this is a psi solution for one s orbital, some s orbital or p orbital, I don't know. So this is a solution for one orbital. In that orbital, I got sin theta cos pi. Sin theta cos pi. Yes, which coordinate? X. Therefore, the orbital must be x. That is a x. Where is the x coordinate? This is that. That is why answer 3px. X component containing orbital is px. Sir, here is there, but all of them they given. That is why I didn't take. I think understood everybody. So what is the purpose first? We have converted Cartesian coordinate into polar coordinate. Why do you convert it? To solve the Schrodinger wave equation in easiest way. In Cartesian coordinate, solution of or solvation of Schrodinger wave equation is typical. Solvation of Schrodinger wave equation in Cartesian coordinate, that is xyz coordinate, is typical. That is the reason why I have converted xyz into r theta pi. How I converted? This is the one. I have given all the things in my notes. This is my note. This is my writing notes. I have written this one in 2012. Yes, really, this is true. Okay, so this is the way I have solved this one. I have shown in front of you. Okay, now darlings, I will go for the next problem. You see, mister, next problem. Do this question. What is the maximum radial distance of node from the nucleus of He plus ion for an orbital 300? And what is the meaning of 300? Psi n l m. N equal to 3, L equal to 0, M equal to 0. That must be 3s orbital. They given psi of 3s orbital. They want to know radial distance of node, and they want to know at what distance the electron probability becomes 0 for this 3s orbital of which atom? He plus atom. Yes, Sai Vignesh.
Sir, option A.
Option
A.
wrong. Could you please once again you try it?
1 minute. B, sir. B.
Yes, exactly. Answer B is correct. Mr. Srinivas.
Option B, sir.
Yes, you are right, Nana. How do you know? When compared to in my previous class, you done very nice. Within seconds, you told the answer. Sir, how do you know? Sir, first of all, I will explain. By looking at this type of question, so many students, you people are somebody are very easy, but my sometimes my type my like me students are there, and slow students are will be there. Okay, that means for them I am explaining now. You please wait, Nana. Okay. What is that, Nana? Here they given like this, and this is a orbital wave function. psi 300. That means psi n l m. Sir, radial node. Radial nodes formula. You please remember that they depends upon distance. That is n minus l minus 1. Angular node. Node is nothing but where the probability of electron density is null. That is 0. They depends upon the what is that angle. That is L. Please remember these points. Node where the probability of electron density psi is equal to 0. Where psi value becomes 0. That is called radial node. Maximum radial distance of node. That is psi square should be equal to 0. Sir, what is maximum probability? Maximum probability, always electron probability we are showing psi square. If psi square equal to 0, automatically psi becomes also 0. Where psi equal to 0 or psi square equal to 0, node occur. Understood? So at this distance, node occur. So that means I have to equate psi value 0. What is the psi? This is the total psi. Okay, this value cannot be 0 because it is a constant. This Z is a constant, Z is nothing but atomic number. Is constant. A naught, Bohr's atomic radius, constant. Both cannot be 0. Sir, exponential power never be 0. So which one become equal to 0? This component only becomes 0. So in the total given question, this component only can become 0 if psi equal to 0. That means 2u square minus 18u plus 27 only equal to 0. Sir, 27 2 sir, 54. 27 2 sir, 54. That means it cannot be written as 54. Then u is equal to, after writing you got that 9 plus or minus, what is that? 3 root 3. 3 root 3 by 2. This is the u value you will get. Minus b plus or minus, what is that? Under root of b square minus 4ac by 2a. Somehow that is. Next, u value. You got the u value. You know already u value they given. U is equal to 2r by a naught. That is r is equal to, sorry, u a naught by 2. Yes, darlings. Then r is equal to u. They given. Have common, taking common 3. If they do common 3, 3 plus r minus root 3 by 2 into a naught by 2. That become r is equal to 3a naught by 4 into 3 plus r minus root 3. Yes, plus or minus, anyone is there. That is why answer become B. 3a naught by 4, 3 plus r minus root 3. Sir, why do you calculate r? R sometimes in the examination they will ask you, calculate the distance in terms of a naught. Yes, in terms of a naught I calculated. This is nothing but radial distance of node. And then at this distance, the electron probability becomes 0 for this 3s orbital of He plus ion. He plus hydrogen like atom. Anybody having the doubts? Am I clearly explained? Okay. If you want, just you once again you see. I will give you the time. Yes, just now I got a message from the government. I don't know it is a true or not. In exercise of the powers and conferred under section 10(2)(1) of Disaster Management Act 2005, the undersigned hereby directs that guidelines of reopening issued by the Ministry of Home Affairs order of even number dated 30/9/2020 will remain in force up to 30/11/2020 for the schools opening. Yes, November 30 no schools. This is the order given from Union of Home and Secretary. Yes, you should not open Kendra Mantritva Shaka. Okay, just now I got a message in my group. Okay, up to November 30, we should not open schools as well as colleges. Understood? Now I will go for the next question, student. I'm sorry. This is the best question. Very, very important question. I think how many students can do this, I will see now. Very, very important. Yoganand Reddy. Tell me.
Sir, 5d square.
Huh?
5d square.
5D Z square.
Yes, sir.
Yes. That means the okay. Student said extended to 30. After that extended. Dinesh Kumar.
Sir,
Sir.
option B only, sir.
Option B, right? How do you know?
Sir, orbital diagram.
Sir, how do you explain?
Sir, orbital diagram, sir.
Orbital diagram? No, that is not the correct answer. Any other?
Sir, if we observe the orbital diagram of 5d square, then it would have torus ring in xy plane and dumbbell in yz z plane.
Okay. Dinesh Kumar, I will give you the chance to read.
Sir, in the question they have mentioned that no nodal planes, so that DZ.
No. No. Then answer 4D square. Why not?
Sir,
Why not 4D square? That is 5D square, 3D square. That means you don't have an answer. This is for every psi function, you have to remember psi r is equal to k into e power minus z r by a naught n into r power l into polynomial of r with degree of n minus l minus 1. And what is the meaning, sir? What is the meaning? Yes, r power L. Here r power L and here L equal to 2. Polynomial degree of n minus L minus 1 is equal to 2. And indirectly, so whenever they given side, you compare your given side with this equation. So from the comparison, I got that L is equal to 2. From the comparison, I got that n minus L minus 1 is equal to 2. For this comparison, L is equal to 2, power is 2. So n minus L minus 1 is equal to 2. If then n minus 2 minus 1 is equal to 2, then n is equal to 5. So I got n is equal to 5, L is equal to 2. N equal to 5 means fifth orbit. L equal to 2 means d orbital. N equal to 5 means fifth orbit, L equal to 2. Therefore, the answer 5D. In that 5D, which D? Now you come to your answer. Those Yoganand Reddy, those another student, what he said, yes, that is correct. In that one, no nodal plane. Yes, student. Yes, student. Nodal planes. No nodal plane. Yes, Akash Kumar, what is your doubt?
Sir, once again, can you tell how you got n minus l minus 1 is equal to 2?
That is the reason. That is the polynomial power. The polynomial power always equal to n minus n minus 1.
Okay, sir.
Okay, the
Okay, sir.
polynomial power is 2. That is n minus 1 is equal to 2. Now you come to your doubts. Now in that one 5D, which d orbital? Yes, they given one logic. No nodal plane. Generally, number of nodal planes is equal to L. Already L is equal to 2. Therefore, number of nodal planes. Therefore, number of nodal plane should be 2. But they given in the data. That no nodal plane. That is must be dz square orbital. Why, sir? Yes, dz square orbital. Even though L value 2, number of nodal planes equal to L equal to 2. Therefore, number of nodal planes should be 2. But dz square orbital has no nodal plane. Why, sir? Sir, this lobe is nothing but electron density. This means also around that is electron density circle like. Now tell me, in this cone, in this direction, no electron density. In this direction also, no electron density. These are called nodal cones. Or nodal regions. So dz square orbital as nodal cones or nodal region 2, but no nodal planes. That is the important. Therefore, the answer is 5dz square. That is why answer is 5dz square. So your explanations are wrong, Mr. Yoganand Reddy, sir, other students, Sujit, I think Akash, Chandra Sai. What is your doubt?
Sir, one scroll up, sir, before question I have.
Yes, ma'am. Okay.
Before question, sir.
Sir? That is the reason why answer should be 5dz square. Answer should be 5dz square. Because nodal planes are not there. Nodal cones only present. If you are quiet, I will give you one more question. You please make it fast. So this equation is very, very important. So comparison of every equation with this. Okay, na? Make it fast. So I think you completed. I'll go for one more question, students. How many can answer this? Yes. Please make it fast. Completed. Not yet completed. Nobody are answering.
Sir,
Sir,
R is equals to 2 or 3, sir.
sir,
R equals to 2 or 3.
not equal to 2 or 3.
R is equals to 2 or 3, sir.
Arun. Divit Reddy.
Sir, PQSR, sir. PQSR, sir.
Wrong. Varun.
PSQR.
PSQR. Wrong. Answer is PQPS. Answer is PQPS. Now you compare once again. So R is equal to K1 into e power minus ZR by A naught N R power L. What is that? R power N SS. Yes or no? R power N minus L minus 1 polynomial. Sir, here power is equal to 2. Therefore, N minus L minus 1 is equal to 2. Is there any R value? No. So R power 0. So L is equal to 0. If you put L equal to 0, N minus 0 minus 1 is equal to 2. Then N equal to 3. I got the two things. N equal to 3. L equal to 0 means S orbital. Therefore, that is a 3s orbital. Okay, now the given orbital is psi 3s. Now principal quantum number N is equal to 3. I got right it. Number of radial nodes. Radial nodes formula N minus L minus 1. N minus L minus 1 already you got 2. Therefore, answer is 2. Next one. Number of subshells having energy between. Yes, darling. That is 3 plus 6 s to 3 plus 6p. Yes, 3 plus 6 s to 3 plus. That is 9 s to 9p. Already I told to you. Whenever in a period, how to general electron configuration? Ns, n minus 1 d. Otherwise, Ns, Np, n minus 1 d, n minus 2 f, n minus 3 g. Okay, please remember that. 2D, sorry, 1P, 2D, 3F, 4G, okay, and 5H are not possible. Please remember these points. If you put in the 9, that become 9S, you put 9, 9P, 9 minus 1, 8D, 9 minus 2, 9 minus 2, 7F, 9 minus 3, 5Z. If you put 9 minus 4H, sorry, that is for 9 minus 4, 5H. 5H is not there. Therefore, the number of subshells between 9S and 9P are 8D, 7F, 5Z. Therefore, again answer 3, 8D, 7F, 5Z. So answer again 3. And orbital angular momentum. Orbital angular momentum given by L. L value 0. Therefore, answer P, Q, P, yes. Anybody having a doubt? You can raise your hand. I can explain one more time. Yes, student. Divit Reddy.
Sir, there 9S90 between 9S90 87 and 5G will be, na sir?
Yes, sir.
Sir, 87F 5G, na, they will be between 9S and 9P or
No,
after
between
9P they will
9
come.
only. Yes, mister.
Okay, sir.
Why not? They are between only. After that only, na.
Okay, sir.
9S after,
Yes, sir.
8D will come. 8D after, 7F come. After 5G, 9P. You write N plus L value. 3, 9 plus S, 9. 8 plus 2, 10. 7 plus 3, 7 plus 8 plus 2, 10. 7 plus 3, 10. Yes or no? And next, 5 plus 4, 5 plus G, 9. And 9 plus 1, 10. So 9 plus 1, 10. In this one, so 9S after 5Z, 5Z after 7F, 7F after 8D, 8D after 9P. This is the order of filling. So between 9S and 9P, who is there? 5G, 7F, 8D. Why not? N plus L value. I think your doubt was clarified. Sir, why do you left from the class? I am observing 10 members or 11 members have left from the class. If you want, I will also left. Don't worry. I am also happy. Sure, Pakka. I can also easily left because I have the leave. What is that? Leave button in front of me only. Huh? Next. So these are the some different types of example questions you require. What is that required? Now I am going to discuss some important things. What are that? Psi versus R graphs. I think you are facing the doubts here. Chandra Sai, where are you? Previously also you raised the hand, but I didn't give. Please. Tell me, Chandra. Oh, sorry. Chandra Sai.
Hello, sir.
Tell me. Mr. Chandra Sai. You see, Psi versus R graphs. How to draw? Sir, in the Psi versus R graphs, S orbital graphs are different. That is Psi versus R. First you see. Psi versus R, Psi versus R, Psi versus R. First I will draw for 1s, draw for 2s, draw for 3s. Sir, for always s orbital, You start the electron density from here. Sir, why do you start from here? Because for s orbital R, how they present s orbital? They are spherically symmetric. S orbitals are spherically symmetric. They are spherical in nature. That is spherical shape. Spherically symmetric. That is why the electron density always going towards nucleus. That's why s orbital has more penetrating power. That is always going towards the nucleus. That means for s orbital at nucleus, electron density is more. As going from that, electron density decreases. Don't touch it. Why it? At an infinity distance it touches. Why you wrote it like this, sir? N minus L minus 1. That is 1 minus 0 minus 1. 0 node. No node. If you go for 2s orbital, again we started like this. 1 node occur. Why do you wrote 1 node? 2 minus 0 minus 1. 1 node. Here for that, 3 minus 0 minus 1. 2 nodes. Therefore, you write the what is the diagram? Yes. Sir, why do you go up and down? Because psi is nothing but both will be present. Positive present, negative present. That is the reason why I draw the graph psi versus like this. Sir, if you draw the graph psi versus R for 2p orbital. Yes, for 2p orbital. 2 minus 1 minus 1, 0 for 2p orbital. For 3d orbital, d start from 3d. 3 minus 2 minus 1, 0. If you draw for 4f orbital, 4 minus 3 minus 1, 0. That means all of them having 0 node. Number 2, they starts from 0 onwards. Why, sir? Because s orbital only spherically symmetric. That's why electron density near to the nucleus is more. But for p orbital, d orbital, f orbital, electron density and near to the nucleus, no, 0. And for gopher, so 2p, 3d, 4f, the same thing. If we write the same graph, psi versus R for 3p, for 4d, R, phi f, or 5 of G. Yes or no? Sorry, phi f. What is that? Yes, the graph become like this. 1 node occur. Why? Because 3 minus 1 minus 1, 1 node. 4 minus 2 minus 1, 1 node. 5 minus 3 minus 1, 1 node. Yes, this is the graph for 3p R, 4d R, 5. Now you go for the same thing for students. I am going to draw psi square versus R graphs. Yes, carefully observe it. Previously you wrote psi versus R. Now psi square versus R graph. Psi square versus R. Psi square versus R. Psi square versus R. For 1s orbital, for 2s orbital, for 3s orbital. Yes, number of nodes for 1s, 1 node. 0 node, that is no node. Same, graph is same. For 2s orbital, 1 node is there. Yes, sir, why do you wrote up? Psi square is always positive. That is why, that is the difference. If you go for 3s orbital, like this, 2 nodes, always positive. That is the difference between psi versus R, psi square versus R. Understood? And we go for this. Psi square versus R. Psi square versus R. For 2p orbital or 3d orbital or 4f orbital, only 0 node. That means the graph becomes same. For psi square versus R. That is the difference. Here negative is there, here positive, but here comes both are positive. That is the difference. 3p and 4d and 5. So here up and down is that it is always up. Sir, why do you start from here? P orbital, D orbital, F orbital. The electron density near to the nucleus 0, but only for S orbital. Only for S orbital. Electron density near to the nucleus is high. That is the reason why I have started from here, but don't touch it, because touching means 0. Near into the nucleus, electron density never be present. I thought understood the difference. You please observe carefully. Next, D versus R graphs. I will explain tomorrow, not today. First of all, please carefully observe. What is the difference? So, this graph same. This graph same. Psi versus 1s, psi square versus 1s. Psi versus 2p3d4f, psi square versus 2p3d4f are same. Okay, now students? These are the some examples. If you want, I will give you one more example for you. I will go for one more example. Wait for 1 minute. Yes. How many have the idea? I will see that now. You see, students? Chukka Vamshi, wait, Nana, 1 minute, Nana. Tell me, Vamshi. Yesterday I forgot to give the notes. Today I will send the notes. Don't worry. Tell me the answer. How many are completed? Yes. Dinesh.
Sir, QRPS, sir.
QR.
PS.
QR. Okay.
PS, sir.
For your convenience, I will write the answer. QR. PQRS. PQRS. And next to PQR. And next to PQ. These are the answer. Check it once. Correct or not? Okay, students, thank you very much. Tomorrow I will bring some more important questions for you. Very important things I will bring.